Trig identities are equations that are true for any value of x inputted into the equation. In order to solve or to prove trig identities, we use the following basic trig identities to help manipulate the left side and the right side. They are all listed up here. Please note that the Pythagorean identity can be rewritten as follows because you often see, for example, 1 minus sine squared theta written in one of the sides, which can just be translated into cos squared theta, and vice versa. We can also use the reciprocal trig functions right here as listed in this top right hand corner. So we'll start off by saying left side and right side. Note that what we have to do is we have to prove independently of each other that the left side looks exactly like the right side. So my right side is equal to 1 minus sine squared x, and my left side is equal to sine x times cos x over tan x. I'm going to start on the left hand side, and I'm going to say that sine x cos x all over sine x over cos x. So instead of writing tan x over here, I'm going to replace it with sine x over cos x. And so what happens here is that the sine x and the sine x will cancel, and this cos x will move up here. And so I'll end up having cos x times cos x, so that's equal to cos squared x. And cos squared x, as we saw right here, is equal to 1 minus sine squared x. So I have 1 minus sine squared x. And I have independently shown, without moving things from one side to the other, that the left side looks exactly like the right side. So I write, therefore, left side is equal to right side, and therefore sine x times cos x all over tan x is equal to 1 minus sine squared x. We can also do this using the reciprocal trigonometric functions. So again, I have to show independently that the left side can look exactly like the right side, or vice versa. So prove that tan x plus cotangent x is equal to secant x times cosecant x. So this one right here, I'm going to say that is equal to tan x plus cotangent x, and my right side is equal to secant x times cosecant x. So I'm going to start on the right side here, and I'm going to rewrite that secant x is 1 over cos x times 1 over sine x. Okay, I don't think I can go any further from there, so now I'm going to go back to the left side. Left side is tan x, so that's sine x over cos x. And cotangent x is just the reciprocal of that, so that's cos x over sine x. And that's a plus, not a multiplication symbol, as we can see. Now I'm adding these two fractions, but they do not have common denominators. So I need to create a common denominator by multiplying each with a factor that will produce a common denominator. So I multiply the first fraction by sine x over sine x. And I'm going to multiply the second fraction by cos x over cos x. Note that this does not change the value of the fraction because cos x over cos x is just equal to 1, and same thing with sine x over sine x. Okay, so sine x times sine x is sine squared x, plus cos x times cos x, that's cos squared x, all over the common denominator of sine x cos x. Well, using my Pythagorean identity, sine squared x plus cos squared x is just equal to 1 over sine x cos x. And if I think about this, that's actually the exact same thing as what I have written over here. 1 over sine x cos x, right there. Okay, just because this has cos x times sine x, remember in multiplication that the order of multiplication doesn't matter. 2 times 3 is the same thing as 3 times 2, so you can just flip the order of the denominator around and you'll see that it's the exact same thing. So therefore left side is equal to right side, and therefore tan x plus cotangent x is equal to secant x times cosecant x. Oh, you can't see that, that's off the screen, so I'll just rewrite that quickly. Is equal to secant x times cosecant x. All right, and that's how we prove trigonometric identities. We split them up into their left side and right side, and without moving things from one side to the other, we show through a series of manipulations and substitutions how the left side can look like the right side, or how the right side can look like the left side. And then we write, therefore, left side is equal to right side, and we rewrite the statement.